Now we're moving on to a very specific type of sequence where we can predict the pattern. This is called let me look at a recursive. And a recursive sequence is a sequence where each term is related to the previous term. So you have to know what came before it in order to be able to solve the existing term. A recursive formula designates the starting term A1 and the nth term of the sequence A to the n. So these little things right here are called subscripts, and their whole purpose is to tell you what part of the sequence it is. So if it's A2, it's going to be the second term, right? If it's A3, it's going to be the third term. So as you go into all of these, just know that those little subscripts just give us more information, okay? All right, so often what we have is a formula that looks like a to the n is equal to a to the n minus 1 plus or minus some number. This is um, signifying what came before, what the last term was. And the reason why this is handy is if you are creating some kind of a computer program and you needed to take some data and then do something with that data, give you new data, and then based on that new data, do something repeatedly until it gets to a certain number, this would be a way to do that. All right, so let's take a look. A to the 1 we said is going to be the first term. So if you take a look, this first term is always, right, that first one that's on the list. So A1 is equal to, for this one, A1 is equal to 23 for here. A1 is equal to 3 for here. Actually, let me pull these out to the side a little bit because I have a funny feeling as we're figuring out these recursive formulas that we're going to have a need to have some space there. So A1 is equal to 3, and then A1 is equal to 4. So we have all of our first terms. The next part of our formula says that we want to take what our previous, so we have a to the n is equal to what came before that, plus some pattern. So I'm going to go ahead and start writing the a to the n. I already have it set up there. Here I'm going to say a to the n equals a to the n minus 1, and then I'm going to leave space. So a to the n equals a to the n minus 1. They all start the same way. All right, so now that I have that, it's a matter of finding my pattern, and we've been pretty good about that. So I look at this section, and I can see to get from 2 to 4, I'm adding 2. To get from 4 to 6, I'm adding 2. To get from 6 to 8, adding 2. 8 to 10, adding 2. 10 to 12, adding 2. So I can say I take my previous number and I add 2. So that is my pattern that I have, and that's my equation. A to the n equals a to the n minus 1 plus 2 for this sequence. It's not so bad. All right, let's look at the next one. To go from 23 to 20, I subtracted 3. To go from 20 to 17, I subtracted 3. To go from 17 to 14, I subtracted 3. So what I'm going to do in my equation is I'm going to subtract 3. Okay, I put that in parentheses because that subscript n minus 1, I guess I write kind of sloppy, so it doesn't quite look the same. So here is my sequence, or my recursive formula, excuse me. All right, let's look at the next one. I want you to go ahead and pause this video if you're watching it online and see if you can go ahead and determine what this is before I finish. So pause it and then we'll go through it together. All right, 3 to 6. What I did is I either added 3, I'm just going to put plus 3, and then from here to get from 6 to 12, see that I'm actually doubling. So I'm going to try times 2 instead of adding. So times 2 times 2 times 2 times 2. Okay, so then what we're going to do is take this, right, this n minus 1, and we're going to multiply it by 2. Okay, so our previous term and multiply it by 2. Okay, so do you see how we find our pattern and then we just add that to the recursive? So again, go ahead and pause this and see if you can come up with the formula, and then we'll come back and do it. All right, to get from 4 to 14, I added 10. 14 to 24, I added 10. 24 to 34, I added 10. 34 to 44, I added 10. So it looks like each time I'm just adding 10. So all I have to do in my recursive is add 10. Now again, I'm putting those in parentheses because my handwriting is really sloppy. So it's difficult to see that that n minus 1 is a subscript. Okay, so there we go as far as recursive formulas. So those aren't too bad at all. You do definitely want to make sure your notes are really thorough on this so that you can do well on the quiz. Okay, so the next one is a very, very special type of sequence. It's a Fibonacci sequence. And I don't know if you've ever read um, some of the books um, of, I'm trying to think of the name of them now, but they were like mysteries. And they used the Fibonacci sequence. The Fibonacci ratios show up all kinds of places in nature. So it's a really interesting sequence of numbers. To get the Fibonacci sequence, if I take 1 and 1, okay, I start with 1 and I add it essentially to 0 and I get 1. If I take 1 plus 2, I get 3. If I take 2 plus 3, I get 5. If I take 3 plus 5, I get 8. So what you're doing is you're adding the previous two numbers to get your new number. So it says, what would be the next 3 terms in the sequence? Okay, so what we're going to do is we're going to start by adding these two numbers. So we're going to have 5 plus 8, and 5 plus 8 is going to give us 13. So I have 13. Now I'm going to take that 8 and I'm going to add 13 to it. So 8 plus 13, and again, I'm just, whatever the next number is, I'm going to go ahead and add the 2 before what I need. 8 plus 13 gives me 21. It's going to be 21. And then I keep that 13. I add 21. 13 plus 21 gives me 34. Okay, so those are my Fibonacci sequences. This is, I would definitely maybe write a description. So each number is the sum of the previous two numbers. Okay, so if I would write it as a sequence, um, I would say a to the n is equal to a to the n minus 1 plus a to the n minus 2, right? So I take the two previous terms. So if I had to write out the actual sequence or the formula, it doesn't ask us for that though. All right, using the recursive formula, now we're going the other way. We have a formula right here, and we're going to find the first 4 terms in the sequence, and I'm going to start at 5.5. So that's the first one in my sequence, and what I'm going to do is I'm going to add 2.1 each time. So 5.5 plus 2.1 gives me 7.6. 7.6 plus 2.1, excuse me, is 9.7. Only the first four terms. So 9.7 plus 2.1 is going to be 11.8. And we have 1, 2, 3, 4 terms. We're good to go on that. Okay, so you're simply just adding that last term. All right, here we start out at -3. And once we have our previous number, we're going to subtract 4. So -3 minus 4 gives me -7. -7 subtracting 4 gives me -11. And then -11 subtracting 4 gives me -15. So here would be my first four terms based on that recursive formula. And then C, I have a to the n minus 1 plus n. Okay, that's a little bit different. So we're going to start out with -5. So then, okay, let me do a2. I'm going to do plus n because this is my n value. It's going to be -5 plus 2. A3 is going to be, let's find out what that is. So -5 plus 2 is -3. So then this is going to be -3 plus 3. That's what my n value is here. So that's going to give me 0. And then a fourth term is equal to 0 minus or plus 4 because that's my term right there. And that's going to give me 4. So my fourth one is 4. Ooh, that's a little bit, that was a little bit tricky. Okay. Notice in most of these, I could just go ahead and list the numbers. When you have an easy pattern, it's really easy to do. If you're just subtracting 4 from each one, it's not a big deal. If I'm looking at something like this where I have to like really actually think about what I'm doing, notice I'm writing out each one. And when I do that, it helps keep everything kind of straight and I know exactly where I got it from. And then when I forget about this in 2 days, I can always come back and take a look at what I did. Okay? All right. So let's look at one more example problem, and then you guys are going to have a progress check too. So example 6, a rubber ball was dropped from a height of 20 feet above the ground. So it started at 20 feet. After each bounce, the ball rebounded to 75% of its previous height. Let a to the n represent the height of the ball after the nth bounce. Write a recursive formula that can be used to model the height of the ball and approximate the height after the fourth bounce. Okay. Oops. So we start out at 20 feet and then it's going to bounce and then it's going to come a little bit higher but not as much and it's going to bounce and it's going to go a little lower. It's going to bounce. It's going to go even lower, right? So bounce 1, bounce 2, bounce 3, bounce 4. Okay. So let's see here. We want let a to the n represent the height of the ball after the nth bounce. So if this is my first bounce, right, a to the 1 is going to equal 20 times 0.75. Okay, so I'm just getting my head around it. And then after the second bounce, A2 would be the product of that. So I need to go ahead and figure out 75% of 20 is 15. So A2 is going to be 15 times 0.75. And then I'm going to get a number. So I think I know the formula. I am going to um, start out with if this is what n minus 1 is equal to, then a to the n equals a to the n minus 1 times 0.75, right? That's my decimal version of 75%. That's why I used 0.75. If I'm looking at 4, a to the fourth is going to be essentially what a to the third is times 0.75. All right, so I'm going to keep working on these. So after my third, oops, let's get the second one. So after the second bounce, 75% of 15 is going to give me 11.25. And then I'm going to do a 3 is equal to 11.25 times 0.75. And then a 4 is going to be, let's figure out what that is. So 0.75 times 11.25 is equal to 8.4375. This is going to be 8.4375. And I said to approximate it, but we're going to go ahead and, while we have our calculators out, go ahead and take care of it. So 8.4375 times 0.75 is going to give me the value of 6.32. So that would be after my fourth bounce. So I have 20 feet. This is 15 feet. This is 11.25 feet. This is 8.4375 feet. And then this is 6.34. This is actually the bounce where you have a lower and lower and lower bounce is called a dampening effect or damping effect. And so this is essentially what your shocks do in your car. So if you're driving along a road and it's kind of bumpy, um, your shocks, if you have really, really good shocks, it lowers the vibration so you don't feel the car going up and down as much. All right, so that is all of our information about recursion or recursive equations, and we're going to send you off to progress check number 2.